Good morning, my geometry students. So Mr. Alent here. We're going to go over chapter 10. This is the part B, right? We did chapter 10A, took a test on that. Now we're looking at chapter 10, part B. Part A was about surface area for these three-dimensional objects. Now we're going to look at the volume of these three-dimensional objects. So the same objects. We're still going to be looking at prisms and cylinders. We're going to be looking at pyramids and cones, but how to find their volumes now. And so to start off, right, with our 10-6 notes, hopefully you printed the packet here and you can be copying this down, following along with me. I want to talk about, what is volume? Volume is the number of cubic units contained in a figure. If you think back to area, area is how many little square units fit into that figure, that shape. Now we're looking at cubic, so little cubes. Think of these as like little dice, right? How many little dice would I fit inside of that shape? That's the volume. And so every one of these little cubes, these little dice you see, they're 1 by 1 by 1 cubes, whatever that unit is. If this was 3 centimeters by 2 centimeters and 3 centimeters, then these would be 1 centimeter by 1 centimeter, 1 centimeter little boxes. Okay, and that would be our cubic unit. All right, so we're just trying to figure out that. That's what volume is. So let's see if we can apply our formulas. Our formulas for these are right here, the volume for prisms. So all prisms, guys, all prisms, use that formula. Okay, and the formula is B times H. And that looks pretty simple. But we have to remember what capital B is. Capital B stands for the area of the base. Now that can change, right? It depends on what the base is. Remember, like last chapter, or the 10A part, the base is a shape. It is not an edge. We're used to, in two-dimensional world, the base being an edge, like a bottom edge or something. Base and bottom are not synonymous, and in three-dimensional world, the base is a face. That's what I always love to say. The base is a face, and we have to know which face is the base. So let's try to figure it out for this example. All right, so we've got this prism here. Now, if you can think about the prism itself, what is happening here, this is a trapezoidal prism. We have this trapezoid in the front and back that is identical. I'm going to highlight it here, just kind of the edges of it. All right. We have that trapezoid in the front and an identical one in the back, connected by these rectangular faces. So this is a trapezoidal prism. So that means, in this example, that our base is a trapezoid. Base is trapezoid. All right, so that's the thing to remember. Base is not an edge when we're talking three-dimensionally. The base is a trapezoid. And so then, again, if capital B stands for the area of the base, right, we always have to keep our mission in goal, our mission in mind. Sorry, my printer was just making some noise there. Volume is B times H, right? So this is our mission. We got to get these, B and H. Okay, and so we're going to get capital B right now with the trapezoid. And so then we just go back to last chapter, go back to chapter 9, when we looked at some new formulas for areas, like the area of a trapezoid. The area of a trapezoid is 1/2 times the height of the trapezoid times the base 1 plus the base 2, the two bases of the trapezoid. So here's where we have to be careful, right? Capital B stands for the base area, but these little b's, we're kind of ignoring the three-dimensional stuff for a minute. We're just focused on the trapezoid itself, its bases, right? So this is where we have to be kind of careful jumping back and forth between two-dimensional thinking and three-dimensional thinking. And so base 1 and base 2. So we're looking at the trapezoids, right? Well, base 1 is that 11 inches on top, right? If it's going to be 11 inches there, it's also 11 inches here, right? So those are both 11 inches. So there's our base 1. Then our base 2 is down here. And remember, for a trapezoid, the bases are the two parallel sides, right? So this guy is parallel to that guy. And so those are our two bases, base 1, base 2. It doesn't matter which one you call which. I could have said that's base 1 and that's base 2. It doesn't matter. But it's the two parallel sides that get added together as your bases. And then the height of the trapezoid, right? That's how far apart are those two bases. So there's that. Now note, this is where you have to be extremely careful. The height of the trapezoid, this H, is not that H. This H stands for the height of the prism, which is how far apart are the bases. So actually, if we want to take that, kind of sidestep for a second. The h we're talking about here is right there. All right, so this is where, again, there's this like jumping between our two-dimensional and our three-dimensional thinking that we have to be very careful of. There's a lot of h's being thrown around that are actually meaning different things. We say base a lot and they can mean different things, so we have to keep this thinking between two-dimensional and three-dimensional thinking. So just be extra careful there. All right, let's get our formula. We got everything's here, so this is the nice thing about this, is there's nothing to find, no like missing side other than just plugging it in. So the height was the 3.8, and then we'll have base 1, which is 11, plus base 2, which is 15. So we'll add those, multiply by 3.8, and divide by 2. When you do all that, you're going to get a 49.4 square inches for the base area. So again, that's the area of the trapezoid bases, right? And the volume says, okay, so take that you just found, multiply it by how far apart the bases are, which is 8. So volume equals that B, 49.4, times the height, 8. Again, height of trapezoid when you're finding the volume of the trapezoid. Or, excuse me, the volume of the prism, right? The height of the prism when you're finding the volume of the prism. Okay, sorry, I said that backwards. And that's going to give us 395.2 cubic inches now, right? We're looking at cubes. How many cubes fit into there, right? So areas in square inches. So this is square inches times inches. So inches squared times another inches gets you inches cubed. Okay? So there's our first example for a prism. Let's look at another example here. This one is a triangular prism this time, right? We have these two triangular faces right there. That one and the back one that are connected by these rectangles. So it is a triangular prism. And so the base this time is a triangle. So base is the triangle. And so if you're finding the area of a triangle, that's 1/2 base times height, where this base, now the little b, this is the base of the triangle and the height of the triangle. So again, here's two-dimensional thinking, right, which is separate from three-dimensional thinking. So if I'm focused on this triangle here, what I'm going to do is I'm going to draw a height down. Now notice these little lines. This means this is an equilateral triangle. So if that's 8 feet, then they're all 8 feet, all right? And I'm going to drop a little height down. I know that's not where we usually do height, but this triangle is kind of funny here. So there's the h that we're going to have to find here in a second. This is 8 here also because, again, the tick marks are telling us it's equilateral. And when you draw the height down, this is going to cut this side of 8 in half. So this little piece up here is 4, which will be important because what I'm going to do is I'm going to look at this right triangle here, and I'm going to use the Pythagorean theorem to find h. Because notice we have a hypotenuse of 8, a leg of 4, and we want the other leg. That is a perfect Pythagorean theorem problem, right? When you know two sides of the right triangle and you want the third. So first, I'm going to use the Pythagorean theorem to find h. And this is the h here. Again, it's not the same h as for a prism. This is the height of the triangle. And so that'll be h squared plus 4 squared equals 8 squared, right? Leg squared plus leg squared equals hypotenuse squared. Go ahead and square the values. Subtract the 16. You're going to get 48. And then when you square root both sides, square root of 48, and we're just going to go ahead and round here. We're going to call it 6.9. Okay? And so back to our base of our triangle, or the area of the triangle, which is our capital B, 1/2 times, now the base of that triangle, I'm looking at this pink triangle here, the base is 8, and the height we just found is 6.9. And so when we multiply those, we're going to get a 27.6 square feet for that base area. Okay, and we can go ahead and now and get our volume of this prism, which is again capital B times h. Capital B was the 27.6. Okay, now here's where you have to be careful. This h is not that h, different h's. This h is the height of the prism, which is right here. All right, so be very careful. The height of the prism, back up to the definitions up here, It's the distance between the bases. How far apart are the bases? That is the height. Right? So 27.6 times 12 will get us our volume, which is 331.2 square feet. Okay. I'm going to go ahead and stop the video here, and we'll do cylinders in the next video just because I'm already at over 10 minutes, and I don't think I'll have time to fit those two in, so we'll just have to have another video for the cylinders. So there you go. There's our part A of 10.6, finding the volume of prisms.